Hello, everyone, and thank you for joining us on our 8th chapter of the AIA Climate Action webinar series. I'm Stephen Hall, AIA, the 2021 AIA California's Vice President of Professional Practice. The events in the event, boy, that's clever. In the event you have missed any of our Climate Action webinar series, including the most recent bonus webinars, be sure to check out the climate action portion of the AIA website for recordings, slide decks, and additional resources. As always, we'll be recording today's presentation, and we'll share both the recording and the PowerPoint presentations shortly thereafter. Our climate action webinar series wouldn't be made possible without the support of our AIA California partners. Today's webinar is sponsored by the National Ready Mix Concrete Association and Woodworks. Don't miss out on their quick tip videos we've shared to AIA California YouTube channel, and they're also available on the AIA California Design for Resources webpage. So thank you, National Ready Mix Concrete and Woodworks, for partnering with AIA California on our climate action initiatives and providing educational opportunities for our members. Now, on today's webinar, as you know, this webinar is centered around this webinar series, I'm a last minute replacement, so I'm sorry. This webinar series is centered around each of the pillars of the AIA National Framework for Design Excellence. Design is not just about aesthetic components, but how buildings perform for people. The framework of design for excellence is made up of 10 measures, formerly known as the COAT Top 10. It organizes our thinking, facilitates conversations with our clients and the communities we serve, and sets meaningful goals and targets for climate action. Today's webinar focuses on designing for resources. When using this lens while looking at your next project, think about safer material selections, material sourcing, embodied carbon, construction waste diversion. Now, before I introduce our speakers, just a quick reminder how to ask questions. If you have any questions, please use the Q&A box, the lower menu bar or of your Zoom window to type in questions to be answered during the question and answer portion at the end of the webinar. For any questions left unanswered, which does happen, our panelists will provide following the webinar. We will also include those in the Design and Resources webpage. So they will be answered even if you don't get to it. Today we have two presenters joining us, Larry Strain, FAIA, and Brad Jacobson, AIA. Larry Strain is a founding principal of Siegel and Strain Architects in Emeryville, California, known for communities serving projects and innovative sustainable design and research. Larry wrote the Green Specs, one of the first guidelines specifications for sustainable materials, and his project includes 3 AIA quote top 10 projects: Emeryville Resource Building Project, 2000, Green Affordable Housing that utilized whole building LCA, Campo Royal, 2002, demonstrated alternative materials, straw bale, rammed earth, and efficient wood framing. And the Portola Valley Town Center in 2009 included a total carbon accounting of the project. Larry served on the board of Carbon Leadership Forum, that's CLF, and on the research team for their Embodied Carbon benchmarking project. Larry has been writing and speaking about materials, carbon, and reusing building for more than 20 years, and for the last decade has focused on reducing total carbon footprint in the built environment. Brad Jacobson, AIA lead AP, is the principal of EHDD, a San Francisco-based architectural firm, which is leading the way toward a carbon-neutral built environment. Brad has led the design teams for a wider range of climate-conscious projects, including 2 AIA Top 10 green buildings, the Net Zero Energy and LEED Platinum headquarters for the David and Lucille Packard Foundation in 2014, and the Department for Global Ecology for the Carnegie Institute for Science at Stanford in 2007. Its current projects range from universities to aspiring net zero carbon office projects with enlightened developers such as the team behind Boulder Commons, a 100,000 square foot net zero energy spec office development, which opened in the fall of 2017. So with that, I'm going to hand it over to Larry and turn my camera off so I don't distract everybody else. Thanks.
All right, let's see if I can do this. Grab this. Where is? All right, are you seeing my screen right now?
We are, yes.
Yes, we are.
Okay, let me put you in. I want to look at the right. I'm trying to get to the full, here we go, full screen mode. All right. And let me go back now. See if I can get back. All right, here we go. I'll get there somehow. So good afternoon. Thank you for joining us. I'm Larry Strain from Siegel & Strain Architects, and I'm joined by Brad Jacobson from EHTD. So today's webinar is really about resources and materials. And as architects, we work with materials every day. They have functional and aesthetic properties that we use to make our buildings with. They also have huge impacts on the planet. They consume a lot of resources. They have ingredients that affect our health, they affect habitat, and they consume energy and generate emissions. So I'm going to talk about some of those impacts in general at the beginning and go through some general stuff, and then I'm going to focus in on embodied emissions from materials and construction. And then Brad and I are going to finish up by showing you a couple of new carbon tools that we're in the process of developing independently. So let's look at those impacts from the perspective of a modest 1,700 square foot home. On this left side, you can see the resources, most of the materials that go into making a home. And when I say modest, most homes today are over 2,400 square feet built in this country. So this is from a few years back. It's a lot of materials, and but what's really important are when you look at the impacts of those materials. So the wood, the lumber, sheathing, and siding that go into this typical house is about a 1/4 acre of forest to make that one house. It's loss of habitat, and it's about 4 tons of emissions for sort of typical wood to process and dry and transport that wood. The shingles is about a ton of emissions to make 2,000 square feet of asphalt shingles. 55 yards of concrete is 10 tons of greenhouse gas emissions. Insulation, fiberglass has got health issues. It's about a ton of emissions. 300 pounds of nails that go into the house is 600 pounds of emissions. So it's more emissions go up the stack than go into the nail itself. Copper wire, lots of environmental issues, and about 1/3 of a ton of emissions just for the small amount of copper in the house. 55 gallons of paint. This is probably out of date now. This is probably better, but when I made this slide originally, it was 100 pounds of VOCs for 55 gallons of paint. Drywall, about 1.5 tons of emissions, and about 5 to 10 pounds of waste per square foot is generated by building that house. So there's a lot of impacts that we're dealing with. Back in the early 90s, I wrote the Green Spec, which was a guideline spec for how to make low impact, how to find and make and specify low impact materials. This is later incorporated into the Green Spec directory published by Building Green. And the first thing we needed to do was come up with a list of criteria for how do you find and select what makes a green material. And we came up with this list on the right and sort of the attributes that generated on the left, on the right. So durable, renewable, biodegradable. These are all, it's a pretty good list, and it's still a pretty good list, even though we came up with it over 25 years ago. But there, if you want a more up-to-date list, Building Green just put out this report in July, which is what makes a product green today. And it sort of lists a lot of the same categories and gets into a lot more details. And this is a great report that Building Green came out with just last month. That's got a lot of detail on this. So that's, I direct you to that. Another great resource that I love are these 12 product rules that some friends of mine put together, which is also available in Building Green. And the one that really is relevant for our conversation today is number 1, which is if you're buying more than a ton of material, know its carbon footprint. And since the average 10,000 square foot building probably weighs between 500 and 1,000 tons in weight, there's a lot of materials you need to pay attention to for carbon. So we're in a climate crisis right now, as we're all aware of, based on weather and fire and everything else going on. And this chart illustrates why addressing embodied carbon is so important in trying to combat that climate crisis. This is a carbon reduction chart, just a general chart about reducing over time, showing carbon emissions on the right-hand side and time across the bottom. If you reduce at a steady state, 10% a year, you'll get to 0 in 10 years, and that's the blue line. If you start out slow, kind of not doing very much, and then as it starts to get worse and worse, you start reducing more and more, that's the red line. But if you start out fast and reduce as much as you can right away, and then ease off as it gets harder and harder to do, that's the green line. The area under each line is the total amount of carbon emitted in that time period. So you can see that the area under the green line is a lot less than the blue line and way less than the red line. So what this means is we need strategies that produce large carbon savings now. And it means that carbon saved now is really more important than carbon saved in the future. We have to really jump on this if we're going to make it. Globally, those embodied carbon emissions are really important. The yellow bars are the embodied carbon, what we build every year between now and 2050. It's kind of a steady state. The blue-green bar is the operating carbon, which starts at 0 and ramps up as each set of buildings come online. And you can see that in between now and 2030, 3/4 of our carbon from a new building will be from the embodied carbon. And even by 2050, half of the carbon from new buildings will be embodied carbon. So we really have to focus on the embodied carbon on this. So if you want to understand, let's define what we mean by embodied carbon first of all, which is really, we use embodied carbon or embodied carbon emissions. When we use those terms, what we're talking about are all the carbon emissions associated with building a building, the materials and the construction process and the transportation that's involved with making a building. And if we want to do something about it, it's useful to know where most of that carbon is. And it turns out that most of the carbon, embodied carbon in a building, is in the materials. There's some in transport, there's some in the construction equipment, there's some in site work, but the majority of it is in materials. And if you want to break the materials down, the majority of that is in the structure, concrete and steel that goes into a building typically. Envelope can make up a pretty hefty amount, interiors, MEP, like that. But where you want to start focusing on is the structure. So let's look at some of those specific materials. So concrete's probably the place to start. It's also the place where you can have one of the biggest differences. There's really great concrete mixes that can cut your carbon footprint in half that are available right now. So there's a couple of things about materials. One are things that architects can do, design things that we can do, and the other things are things that the industry is doing. So we can reduce the cement content in our concrete, make better lower carbon concrete mixes. We can actually reduce the amount of concrete with efficient shapes and design, working with our structural engineers. We can use lower strength concrete when it's appropriate. And these all come up with various kinds of reductions associated with them. And then industry is also working on this, which is really great. They've made huge strides in making better lower carbon concrete, and it's a lot of mixes available now from your ready mix companies. And they're even working on some alternative concrete mixes with carbon sequestering concrete, which is basically, people are working on taking the emissions from power plants, taking those emissions and turning it into aggregate and cement for concrete manufacture. So there's a lot happening here. Let's see, where am I here? Okay, steel. Steel's another huge impact. It's almost as much as cement worldwide, but only half of the steel worldwide is used in buildings. But it's still a huge impact in buildings. And the thing to know about steel making is, again, there's things you can do in design. You can reduce the quantity of steel through efficient design and efficient shapes, but you also can specify lower carbon steel. And the easiest way to do that is just understanding where your steel comes from. Steel comes from either basic oxygen furnace steel, and that typically is hollow structural shapes and steel decking and a lot of the sheet products. And then the electric arc furnace steel is typically made from recycled content, and it uses wide flange, angles, channels, rebar, and that has a much lower recycled content. I mean, much lower carbon content, about half the carbon footprint from electric arc furnace steel as from basic oxygen furnace steel. So again, just understanding that and limiting the kinds of steel that comes from BOF furnaces and working with steel there, but also, again, trying to, through design, reduce the amount of steel in your building. Aluminum we don't use a ton of it, but it's a very high impact material. Typically, US average, I think, is for every ton of aluminum, there's 9 tons of CO2 generated. So it's a 9-to-1 ratio, which is pretty intense. And the range is all over the map. The range for aluminum worldwide is anywhere from 3 tons per ton up to 20 tons per ton. So it's one of those materials that you want to use sparingly. If you can source good sources, aluminum from Iceland's great because it's all geothermal power, but that's probably a limited supply. Again, best practices, avoiding aluminum or using it sparingly. And then there's wood. So wood is a low carbon material. It can be a carbon sequestering material. There's some carbon emissions actually to process wood. But the thing to understand about wood is when you're counting up how much carbon it generates and how much carbon it stores, it's not just the piece of wood in your hand. You start with the live tree, you cut it down, there's logging residue, which you don't get to count in your product. And then there's the mill residue. So you end up with a wood product that only has a fraction of the carbon that was stored in that tree. And the rest of it is not stored, not sequestered. So the thing to understand about wood is that really wood doesn't sequester carbon, it stores carbon. What sequesters carbon is a living forest. So what matters about carbon sequestration with wood is really finding forests that use the best practices possible, certified wood or forestry practices that really take care of the forest, make sure that the forest health stays intact as they log. And you can keep a lot more of the carbon in the trees. And it turns out a lot of the carbon is actually in the soil too. So you don't want to disturb the soil as much more than you have to. So there's a lot we're learning about wood and how do you really count how much it sequesters. But it's definitely a great alternative to steel and concrete. And picking the right wood really matters. And this just shows this chart for a project that some people were working on that looked at wood from different forest patches in Oregon and Washington, and the range was the highest carbon intensive material was higher than concrete and steel from a forest, a badly managed forest in Oregon, and the best one was from an FSC forest in Washington, and the range went from carbon sequestering to a huge amount of carbon emitted. So it's really critical to know where your wood comes from and to try and advocate for best practices. So I'm going to look a little bit now at where the carbon is in different kinds of buildings. And I'm really oversimplifying right now, but sort of large, heavy buildings, which typically are concrete or steel construction, steel structure, is somewhere between 50 and 100 pounds a square foot. And it can be much higher than that, but that's kind of the general average. Light buildings like wood frame residential homes is sort of in the half of that, 30 to 50 pounds a square foot. And then there's this category which is reuse, which is to sort of reusing buildings and even remodeling them, but not leaving the structure and the envelope alone typically, where you're remodeling, doing major remodels, maybe replacing the MEP equipment or drywall, carpet, is about half of that again, 10 to 30 pounds a square foot. So you can sort of see that large, heavy buildings, you really need to pay attention to concrete and steel, where that comes from and how efficient they are. Light buildings, is better if we build more of that, and then reuse is really a good strategy for lowering our carbon footprint, is to reuse more buildings. So the first time I really became aware of all this was when we finished this project in 2009. We designed this with Goring and Strachan Architects. It's a town center in Portola Valley, a very green project. It's a COAT Top 10 project. It's very efficient, a lot of PVs. And we decided when we were done to go back and count up all the carbon inputs that went into making this project. And this was a long time ago. So we used the ICE database, which I'll talk about in a minute, not a calculator because they weren't available then. And we were able to reduce the embodied carbon without trying too hard by about 32%, just by focusing on the concrete mixes. And then we used a huge amount of salvaged wood. We had 20,000 board feet of wood that was salvaged either on site or off site and used in the project. And the reason that bar shows up as the blue bar, which is our project, is blue, shows up as negative, is that not only did we avoid all of the processing and drying and harvesting of that new lumber, but we also, that salvaged wood does not go into landfill and eventually decompose. And also the trees that we didn't cut down are now still standing sequestering carbon. So it becomes a great way to, turns out salvaged wood is a great way to avoid carbon on a project. So 32% is great. I think if we'd paid more attention in the design phase, we could have gotten this a lot lower. But there's a lot you can do right now with materials. An even better way is to look at reusing and upgrading existing buildings. This is the DPR office building in San Francisco. It's a net zero remodel. We were not the architects. We just did a study of the project when it was done. And we found out some really interesting things. We modeled this project in Tally. Integral Group worked on this with us and they modeled it in Tally. And we looked at all the materials in the project, and the hatched materials are the materials that were reused in the building, and the solid materials are the ones that were new into the building. So the remodel has all the solid things. And what they ended up with was about a 70% reduction in embodied carbon over a new building of the same size and type. So there was a huge reduction there. But the other thing, which is going to lead into some of the things Brad and I are going to talk about in a minute, which is the total carbon of this project was even greater. The savings we had here, there's that 70%, about 650 tons of carbon saved in the building reuse, but we also went from a gas powered heating to no gas, it's all electric now. Efficiency upgrades and PVs took us to a negative number, so this is a net positive building. So the total carbon reduction over 20 years was almost 6,000 tons. And most of that was operational carbon. So it's important not to forget about the operating carbon when we're talking about total carbon reductions over time. We don't like to look beyond 20 years because we figure if we haven't solved this in 20 years, we're in trouble. So we're looking for solutions that give us big savings within the next 20 years. Let's see, what did I do here? Oop, go back here. So I'm going to talk a little bit about tools. And just different kinds of tools. And I go through these in a little bit more detail, and then Brad and I are going to go into more detail on these two at the bottom, these estimating tools. So the first way to understand carbon and measure carbon is to use best practices and just rules of thumb. Then there are materials like material information like EPDs, environmental product declarations, and tools that work with EPDs or that work with just sort of databases that show you embodied carbon footprints for different material types. Then there are calculators, whole building calculators, such as Athena or Tally or OneClick, where you can plug in the materials in your project and it'll give you the embodied carbon footprint of the material and the whole building. There are some benchmarks, which are important to talk about, and estimating tools. So let's just go through these quickly. So best practices. This is an AIA embodied carbon, what you can do right now that came out that basically is just a list of best practices on how to reduce embodied carbon in a project. And it's sort of in order of importance in my opinion. So reusing and upgrading existing buildings, specifying low carbon concrete are two of the top things you can do. And then down the list, these other things all reduce carbon in a project. There's also a really great resource put out by Architecture 2030 called the Carbon Smart Material Palette. And they've looked at, they keep adding more materials, but they've got a number of materials, including concrete and steel and wood, where they look at sort of what the impacts are, how it works, and what the best practices are. So this is a more detailed version of the list on the right in some ways. And it focuses on specific materials. Keep doing this, let's see here. So then there's looking at specific materials and EPDs and databases. So the ICE database has been around for, well, since we did the Portola Valley Town Center, we used it as a database. It's out of England, so it's not totally accurate to North American numbers, but it's not that far off. And it's a great way just to get a general understanding of sort of the embodied carbon footprint of all the materials that go into buildings. And they have a lot of detail in this database. It's a really good way to get a general understanding of the carbon footprint of different materials. Then the EC3 tool, which just came out, I guess a year ago, is a great tool. It actually, you can compare embodied environmental product declarations for different materials, and it really gives you a great way to sort out materials and look at them. So it's a way of looking at things very specifically. It's not so much a whole building calculator right now as a looking at and comparing different materials, and it's really tied into all the EPD databases. So it's a very powerful tool that's really useful. Then there's the calculators, the Athena Eco Calculator, both for commercial and residential assemblies, which has been around for a long time, and it's really a great way to look at the embodied carbon footprint of an entire building. Tally works with as a plug-in for Revit, so it works with a Revit model and generates environmental information, including global warming potential for different materials and for the whole project. And then this one-click, which I haven't used yet, but it also is similar to Tally in many ways. And I think all of these, the Athena and one-click, I think also offer LCA consulting. If you don't want to do it yourself, you can hire people at Athena Institute or one-click to do the LCA calculations for you. Benchmarking, I think, is becoming really important if we're trying to figure out where to focus our energies on. We need embodied carbon benchmarks the same way that we got energy benchmarks after the 70s energy crisis. We started developing energy benchmarks for operating energy. We need this. This was the study done a few years back that I was part of, where we really tried to look at setting benchmarks. And you can see these little whisker charts. There's a lot of variability right now still in the data, and what we're trying to do is get hone that in and get better quality data, so you can sort of say, in general, this type of building is roughly this footprint, and that's tricky to do, but we're working on that. And then the final two tools that we realized we needed is ways. It's important to be able to work with embodied carbon estimates early on in a project before all the decisions have been made. And so both the tool that Brad's working on and that we're working on is a way to sort of get a quick take on early decision making you can do with materials. And I'm going to let Brad talk about his tool in a minute, and then I'll talk about mine, and then we'll finish up. So I think we're to Brad now.
Okay. Hi, everyone. So I've been listening to and learning from Larry for about 20 years, and each time I hear him speak, I learn something new. So thank you, Larry, for leading us all through this for so long and so effectively. So my firm, EHGD, we're an architecture firm, San Francisco based. We recently committed to what you see on the screen, a climate positive vision. And it's building on work we've done for 20 years or so on net zero energy buildings, energy efficiency, low embodied carbon materials, but trying to put it together in a way that gets us where we really need to go according to Paris Climate Accords and science that says we need a carbon neutral built environment in the next decade or so. So it's a tall order, and it's going to take doing everything, electrifying everything, decarbonize materials, really getting serious about transforming existing buildings, resilience, and advocacy on all our parts. So next slide. So as Larry just kind of mentioned, go back one, I think.
There we go.
Thanks. So when we committed to this, and then we looked around and we're like, how are we actually going to do this on our projects? How do we figure out what our overall carbon picture is, putting it all together, embodied, operational, and then how do we get information at the earliest stages when we can have the biggest impact, where we can advise the client whether it makes sense to build new or renovate, when we can advocate for a mass timber structure, when we can look at electrification, or these big decisions. And that's why we developed this tool that we're calling EPIC. Next slide. So this tool stands for Early Phase Integrated Carbon Assessment. And it complements tools like Tally and EC3 that come in later in the process and allow you to really refine either your material selection or your strategies. But it does, what EPIC will allow us to do, or does allow us to do, is identify where are the big levers and how do we compare operating to embodied carbon, and help us advise our clients if they're really serious about carbon neutrality as to where we need to go. Next slide. The other important thing about the way we're looking at it with our tool is that it's a life cycle analysis at a very high level. So we know we have a limited time to solve this problem. We have 10 years, 20 years, pick your time period. But what we're able to do here is set a target, say we wanted a building to be carbon neutral by 2040, and then find solutions that allow us to get it there. So on the left is the baseline, looking at in gold the operating emissions, starting at 0 year 1 and building up over 30 years. And then the embodied emissions in blue that are more or less constant, plus or minus, over the life. On the bottom then is a hypothetical building that's getting to carbon neutral by 2050 through reduction in embodied emissions, kind of flattening this curve of operational emissions, and then doing sequestration in green that allows you to bend down that black line to get to 0. Next slide. So just quickly, I'll show you the two main pages of the tool. The first page is a baseline setting where, and the goal of this tool is to be super high level and very easy for anyone, really, any designer or building owner to use. So you enter in a name, when the project will be done, how many floors, how much square footage, the baseline structural system that you would assume, steel, concrete, wood, the use of the building, the zip code so we know where it is, how much site area. And what you see on the right then is the baseline that shows for this particular building over 30 years, a little bit more than half of the carbon would be associated with the orange operating carbon, and the remainder is embodied, and there's some sequestering going on just from the site landscaping. Next slide. But the meat of the tool is here, where you can start to play with these levers and figure out how to get that carbon down. It's hard to see, it's small, but up on the top there you have building structure reuse percentage. You can identify how much of the structure you can retain. Moving to the further right, embodied carbon measures. So how low carbon will the concrete be? Can you do mass timber? Will it be responsibly sourced mass timber? And then moving down envelope, tenant fit out, how, you have toggle between low, high, medium carbon. You can show your assumptions around how clean the grid will be, what your EUI, what your energy efficiency will be on the project. Are you going to electrification, on-site solar, clean power purchase, all these big ticket items. And on the bottom, it'll show you in real time how you kind of bend down that curve, that red line, to get back to 0 and get to carbon neutral. Wow. So to close in, where we're at now, this is in beta phase at EHTD. We're using it internally for now. We're testing it out, figuring out how to improve it, getting some peer review. And our intention is to roll this out to the public, hopefully in a web interface in the coming year. We're looking for partners now to help us develop it, and we're excited about what it could do for practitioners, AIA members, and others.
Great. Thanks, Brad. This is when I saw this about a month ago, and I got very excited because we've been working on something similar, and Brad's ahead of us in many ways and done a really great job on this. So this is fabulous.
Thanks, Larry.
Yeah. So let me talk about our tool, which is got the same idea in many ways, but its main focus is on this question of whether we want to build new or remodel and upgrade. So this is my thesis about why existing buildings matter. We have a lot of them. They have a lot of materials. They're not very efficient if you're taken as a whole, and we can't really afford to replace them all from a carbon standpoint. It takes too much carbon to build new buildings. So you've seen this pie chart before, which is 28% from operations and 11% from embodied. But what the point I like to make with this pie chart is the operating emissions are mostly from existing buildings. In fact, by definition, you can't have an operating emission until the building exists. And embodied emissions are mostly from building new buildings. So another way to look at those two pieces of the pie chart is that operating emissions are new, embodied emissions are, backwards. Operating emissions are mostly existing and embodied are mostly new. So the calculator works, compares embodied carbon, operational carbon, and what we're calling avoided carbon over different time frames. And right now, our beta version has these different scenarios. We have a baseline existing building. We have a new building on a vacant site, which is just if you're building on a greenfield site, what would it be? And you have a replacement building. So you're taking that baseline building and replacing it with a new building. And then the final scenario is reusing and retrofitting that existing building. We looked at both. So the embodied carbon is based on mostly from the CLF embodied carbon benchmarking study and some other studies and work that I've done over the years. And again, we started out with this sort of heavy concrete steel frame building, the light building, which I've sort of averaged them out here, the reuse existing, and then eventually we want to get into a carbon storing building using carbon storing materials, but that's not in the beta version yet. So that's where the embodied carbon comes from. The operational carbon, the existing building is based on the CBEX database from 2012, and they do it by building type, and they just assign EUIs for different building types. The efficient new building is assuming a code compliant building. It's basically following the 2030 challenge, which is that right now an efficient building built today would be 80% more efficient than the CBEX 2012 building. Retrofitting a building, again, 2030 is saying 50% more efficient than the existing. And then we have a zero net carbon option, which is basically an all electric building using powered by renewables. So then you enter your project data, just like in Brad's, you enter the climate, the state, the climate, the office, the primary type of building, the floor area, and the operational time frame you want to look at. This is what our screen looks like currently. So you enter that project data up there, and it puts out embodied emissions in tons, operational emissions, and total emissions. And what that does then is generates a chart. In this case, it breaks down operational avoided, embodied, and embodied avoided for these different options. So the existing building, there's no change in the building. All the emissions from that existing building over the next 10 years are going to be operational. You're not doing anything to the building. The new building, almost all the emissions will be embodied emissions. There'll be a little bit of operations from the 10 years of operations you've got for the efficient building, and there'll be no operating emissions from the zero net carbon one. The replacement building, you start getting into operational avoided emissions, because you're comparing this back to that existing building. You're saying, well, if we'd left that existing building alone, we would have had all those emissions. So we're basically counting the this energy saved by upgrading that building to either efficient or upgrading it to net zero. And finally, there's the retrofit option, where you both have operational avoided emissions, and you also have embodied avoided emissions. Now you're comparing the embodied back to this new building. So you're not building that new building. And what that ends up with is a chart that looks something like this. And it's interestingly, I'm not going to show you all the different variations, but if you change the climate zone or change the state, this will look different. If you go to this is a pretty clean grid and a pretty benign climate. If you go to someplace like Kentucky, it's got a much more humid, hot climate, and it's also a much dirtier grid. And so all the operational numbers will go up. So it changes depending on where you are in the country. So that's kind of where we are right now. We just found out a week ago that we got a grant to continue working on this from one workplace is giving out grants for innovation work. And so we're going to continue developing this. And what we want to do is add a lot more types of buildings and their associated embodied emissions and a lot more types of renovations. So our benchmarks won't just be this heavy building, light building, and renovation. It'll be lots of variations. We're going to add a carbon sequestering materials option and more choices for operational emissions and for new and reuse. So there's a lot more work to do on this. And we're even going to hopefully talk to Brad about maybe we can combine forces because we're doing some of the same things on this. We're just focused more on the existing buildings.
Mm-hmm.
All right. So I think this will be available. It's up on the website now, but this is a lot of the resources that I talked about. This is data, how to get to them. Organizations, Carbon Leadership Forum's doing really good work in embodied carbon. That's sort of their focus. Architecture 2030 is doing work in all kinds of carbon, but they're really starting to focus on existing buildings and embodied carbon. New Buildings Institute has done a lot of work with this. Rocky Mountain Institute, AIA, all are working on these things. So I think that's pretty much it. And I think we're now available for questions.
Yes, excuse me. Got me a little off guard. You're earlier than most. Thank you, Larry and Brad, for a great presentation.
Yeah.
I'll now open it to the floor for some question and answers. Any questions that you're unable to answer today, I'll remind people we'll provide additional resources on the Climate Action webpage. So just a reminder, we already got, well, there's 4 questions now. Just on the Q&A box located in either the lower or upper menu bar of your Zoom window. So I'll start out with Angela's question. Is there any less expensive program like one-click LCA for new emerging architects to perform our projects collaborating with other communities?
I don't know of others. I haven't used one-click myself, so I know of it, but I'm not very familiar with how it works. I don't know if you've used it, Brad.
Our consultants have used it, and it's definitely an elaborate. A lot of these LCA programs are kind of intensive and important to do, but they do charge for them. I think that's partly the goal that we have with our Epic tool is to make it available, and it's not going to give you the finest tuned result in terms of exact numbers, but it'll help guide decisions. So. But I don't know of other free tools actually.
The other one that's free, that's not, which is the database. The ICE database is a really great way to sort of get your head into where the carbon is in the materials in your building. And you can just look through the concrete and steel, and there's a whole lot of different entries for different types of steel, different types of concrete. So it gives you a sense of where the big impact materials are and how to address them. It's not really a tool, a whole building tool, but it's a great individual material tool.
Mm-hmm.
Okay, Tyler has a long question for you, Larry, so I'll try to read it. It's on the Bauer building that we worked on. I think our model showed that the use of concrete on that particular project was lower from a life cycle carbon comparison due to the lower EUI it created over light frame. I think it was calculated with the grid CO2 footprint at the time in general. And would you agree that the most renewable percentages we put into our grid, the more we will add to value upfront, to the upfront and embodied carbon in our buildings, increasing?
Yep.
Yes. I would say that. The one thing that I think we need to be careful when we look at life cycle impacts of a building is that a lot of those life cycle impacts are, the default is 50 60 or 100 years. Those are meaningless numbers for us right now. We have life cycle. We have to be positive in 10 to 20 years. So I've moved away from always thinking that high thermal mass buildings are a good idea. Just because there's so much concrete involved, you may not get that energy savings back in the time frame we needed to get it back in. So that's really what worries me. That's why I think we have to be careful of using that.
Yeah, I would definitely agree with Tyler that that's what we've started to see, that if you look out over even, California's policy is that by 2045, we'll have a zero carbon grid, which effectively means that there is no operational carbon emissions by that point, and it'll get very close to that point even sooner than that. So that is, I think that's fueling a lot of all of our shift to taking embodied carbon even more seriously than before.
Right, right.
Actually, I have a question I can answer. Victor asked, will the slides be available? And yes, they will be posted on the webpage fairly soon after we end this thing. It's a couple of days. Don't expect it to by 1:15 that everything's posted, but everything will be. And I think that's because you want the live links in the PDFs or the PowerPoint, correct? And that's also will be available and is I believe already on the site.
Right.
So John asks, many of our clients are looking for a shorter term ROI and design decisions. Carbon is trumped by first cost concerns.
And what strategies would you suggest? Well, while you think, Larry, I have one answer to that, which is, yes, admittedly, carbon is not yet as valued because it doesn't show up as unlike, let's say, energy costs. But if you take something like electrification versus adding gas to a building, it's becoming very clear that the risks for our clients who are going to own buildings for a decade or more of having gas infrastructure and having to likely replace that infrastructure in the life of the building is significant because of the way legislation is moving very quickly to ban gas, and that's going to drive gas costs way up over time, because there's gonna be less and less customers to maintain these lines. So there are ways, it's a more sophisticated conversation, I guess, but there are ways to talk about mitigating risk for costs in the future for our clients who are owning and holding their buildings.
Right. Yeah. And I mean, we have to get serious about this conversation that carbon matters. First of all, one of the things we're seeing too with this conversation of electrification versus gas is, if you just look at the emissions of natural gas kind of at your burner, it's one thing. But if you actually look at the emissions in the whole system, it's a much higher emissions. And so people think of gas, for instance, as a pretty clean alternative, so it's not that bad to use it. Turns out it's actually a lot worse than we think it is, because nobody's counting, or at least the people that count emissions aren't generally counting the total emissions of the system. So it's something that I think if you start to get clear with your client about how bad some of the burning fossil fuels on your site really is, sometimes it helps too. It's not a very good, I'm terrible at making the money arguments. That's not my thing, but.
Yeah. John did have a follow-up to that, which I think you actually answered, is how do you sell the carbon? Carl asks, is Larry's tool, Carbon Positive 20, already available for users?
It's not quite there. We thought we were going to release the beta version, and there were just too many little glitches and errors. We didn't want to do that. The grant we got is a 5-month grant, so we have to have something doable within 5 months. And I'm hoping that it'll be sooner than that, like 3 or 4 months. Like probably by the end of the year, we'll have something that we might be able to release as a beta version for people to start playing with. Because what we're also looking for is then input. Right now, as Brad's tool, it's an Excel tool. Eventually, we want it to be a web-based tool, but getting feedback while it's still Excel would be useful. So stay tuned, stay in touch with me, that's fine. I just don't, it's not quite there yet.
Scott said, it's great to see your calculator, Larry. You're using 80% below CBECS as a baseline for operation energy, but few firms are meeting that goal. would using the average firm performance for the 2030 challenge be more accurate metric? Even the firms reporting 2030 data are probably outperforming the average.
Yeah, so I developed this tool with Aaron McDade from Architecture 2030. So a lot of the 2030 goals and challenges are kind of baked into the tool. Because the only number that's sort of the benchmark is the existing building. The new replacement building, we're sort of trying to be aspirational with that goal. If we were putting in a sort of average efficient building built today, it wouldn't be meeting that 80%. You're right. So that's one of the refinements we want to look at, is to have more options you can select for what you choose to say your new building is going to be. Is it going to be what your typical building is? Is it going to be the 2030 aspirational goal, or is it going to be a net zero building? So, yeah.
Right. Tyler's asked a question about wood, when a new wood structure was entered into the bar graph comparison, it didn't appear to be negative. Is this because the processing delivery of that wood outweighs the embodied carbon in the wood that makes it into the building, or is it due to another reason in the way that wood is accounted for in models?
Yeah, I don't like to count wood as negative unless I really know where it's coming from, and I will count salvaged wood as negative because it's clearly you didn't cut down a tree to get that wood. But you're really counting the carbon in the system, and the system is the forest. And if the forest, the way you harvest it and manage it and take wood out of it and build in logging roads and all that, if that's the impact that really matters. And that's where most of the impact in wood is trying to keep our forests sequestering. Right now they're sequestering, I think 11% of our US emissions are sequestered in our forests. We want to keep that number at least where it is and hopefully drive it up. And if you start doing forestry in a way that makes that number go down, then you're actually making things worse. If you can drive the number up, you're actually resulting in fewer net emissions. So it's that the forest is not encountered in those. The carbon in the wood is actually a fairly minor component compared to the carbon in the total system.
Yeah, I'm going to ask take a privilege here and ask the question myself. One of the things I used to push for in designing projects is to minimize waste by using modular forms, like 4 foot on center or 16 inches on center, instead of, I had a project where they had to buy 10-foot studs to cut off a foot because was not a standard length stud. So can that be incorporated into some of, for construction waste?
For sure. I mean, you've done work with this too, Brad. I mean, just trying to modularize and lay your building out on a 2-foot module and all those kinds of things where you're trying to work with the materials and the standard sizes they come in and work to those sizes and frame your windows in those size modules and all kinds of things. I mean, there's people that really get into this and can get, I think that typical framing factor in a California home is like, can't remember what the percentage is, but it's really high. It's like 30% framing. 30% of your wall is solid wood when you take into account all the headers and trimmers, and you can get it down to a quarter of that by really careful framing. So that's a huge way to save material, which also generates less waste.
But
I'm sorry, go on.
Just one thing, but that's a great example of where you are in the project process. You're wanting to look at different questions. So that's hugely important. You're in design development, you're in construction documents, you're in construction. You got to be focused on those issues. When you're just at the interview, or you're just putting pen to paper, you're looking at is it all electric? Can we go to mass timber? Can we, like all those, can we reuse the building? And I think you can't let up at any point in the process. There's always something to be working on that really make a big difference.
Right.
Okay. Michael asked a question regarding the increased risk awareness of wildfire and soon earthquakes and other calamities, which also wants us to design for structures to survive these. Is this factored into the carbon reduction?
Yeah, currently not. It's a really good point. I mean,
Yeah.
if you design a building that falls down in the next earthquake, that's a lot of wasted resources right there. And if it burns down also. So we do a lot of work in urban wildland urban interface. And so we pay a lot of attention to making our buildings as fireproof as possible. Doesn't mean we don't build with wood anymore, but they're now fire hardened on the outside so they don't catch fire the same way. Yeah, ideally all those things would eventually be calculated in, but it's hard to put an actual number on a risk. In other words, it's going to happen maybe someday, but we don't know when.
Although for some of our projects, some of our clients who are interested in this, we've done with our teams these risk analyses around earthquake damage, and you can get it down. There is a science to doing this kind of Monte Carlo analysis, as it's called, and looking at probability of an earthquake, the cost of upgrading the building, and how much you're paying for replacement costs. And so it's a really interesting analysis, and usually shows that if you're being rational, it pays in most of California to spend more on earthquake resilience.
Right, right.
Kenneth asks, how are recycled wood materials tallied? Labor costs are high to deconstruct, clean, mill, and reinstall, and many woods become harder to work with. Are you taking all the aspects of reuse into consideration? I love the concept of reuse, but question financial impact and ability of small scale projects to accommodate.
Yeah, I mean, those are all true. I mean, at the moment, I was just looking at the carbon impact. I was not looking at all those other impacts. There are things you can do to make deconstruction and reuse easier, and how you write your specs, and how in working with deconstruction contractors instead of demolition contractors who actually understand how to take a building apart. It's not easy. We've talked about it for years. We've only done it on a large scale on that one project, although we've done it on many projects, but at a much smaller scale. So it's not an easy thing to do. But I still think it's one of those things where if we're looking at mass transformation of how we deal with materials in the next 10 years, that's going to be something we need to look at, is how do we design buildings that can be deconstructed, which Brad has done, and how do we design, buildings how do we take buildings apart that weren't meant to be deconstructed and get as much out of it as we can. The new sort of sink of materials we have is not in our forests and our resources, is not the existing cities and buildings we already have. We're going to start using those. We're going to start mining those resources, I think, because we just don't have the carbon budget to do anything else.
It's kind of an interesting question. There's a house being torn down near us that they have already taken all the windows out and recycled a lot of the materials. So,
right.
It's from the 40s. Lori asked stated that the California legislature is attempting to force tremendous amounts of new construction in older neighborhoods by revoking R1 zoning and allowing multifamily on these lots. That wipes out all the conversation of embodied energy practices. Can you comment on this policy? Is there any way to get developers out of public policy?
Well, I don't know. On the other hand, we have a housing shortage and a housing crisis. So you sort of have to look at densification. One of the things working against reusing existing buildings is that there's a higher, better, best, denser use for that site, and that's really hard to argue against, both for economic reasons, but so it makes sense to tear down buildings sometimes. I'm not saying it doesn't. Sometimes the amount of embodied carbon in a single family home that you're then replacing with a 6-story or a 6-unit building may be worth that, taking that building down. So I just think we have to, it's not that we don't stop tearing buildings down, we don't stop building new buildings. It's that we need to be more conscious about when we take a building down and look at, really, is this the best use? And the carbon argument has never been made for that. It's always been economic or use or density. And I think we have to make a carbon argument.
We're right at 1 o'clock, and I have some closing remarks, but we have one last question, so I'm going to try to sneak it in from Lay. Are you working with any international research members, teams for your development? When will you be starting to beta test?
How about you, Brad? Got international?
We haven't started to build in international data. We've been focusing on getting a national, really good, and actually that's some of the next steps is to get even better, finer grained regional variation. So we don't have international beta testing. We're doing it internally at this time and intending to roll it out within the next year.
Okay,
Yeah.
I gotta help close up here. Now, if you all made it this far, AIA will submit you for AIA HSW credits. It should appear on your transcript within 2 weeks. We'll be sending out today's recording, PowerPoint presentations, and any additional resources tomorrow. Thank you again to our partners, National Ready Mix Concrete Association and Woodworks. As always, more resources and tools can be found on AIA California's website, aiacalifornia.org/climate-action. And we look forward to joining us on our next webinar focused on designing for well-being. That will take place on Thursday, September 24th at noon as well. Again, Brad, Larry, thank you. Deborah, did you want to say anything, or
Thanks, Brad.
you're happy listening? Good enough. All right. Yeah, there are a couple more questions going through. We'll hopefully they'll be answered before published.
All right.
Thank you, everyone.
Thanks.
Thank you.
Thanks.
Bye-bye.